Research and development, or R&D, is the lifeblood of innovation. It's the engine that has propelled the United States into global leadership in technology, medicine, defense, space exploration, and countless other fields. But what if that engine suddenly slowed down? Dramatically. Imagine the US government announcing that, starting next fiscal year, it would slash its R&D budget by a staggering 40%. Overnight, funding for cutting-edge research, futuristic technologies, and scientific breakthroughs would be stripped away. The laboratories buzzing with discovery today might fall silent tomorrow. The impact of such a decision would not just ripple, it would thunder through every layer of American society, industry, and the global economy. First, let's grasp the scale of what we're talking about. The United States currently spends hundreds of billions annually on R&D, split between federal funding and private sector investments. This spending fuels the National Institutes of Health's medical research, NASA's space missions, the Department of Energy's clean energy projects, and the Pentagon's development of advanced defense systems. Universities rely heavily on government grants to conduct basic science, the kind of research that doesn't make money immediately but lays the foundation for future industries. Cutting 40% from the federal R&D budget would rip a massive hole in this ecosystem. And unlike trimming a household budget, you can't just cut the fat without hitting muscle and bone. One of the first and most visible consequences would be in healthcare. America's medical research is the envy of the world, not just because of its scale, but because of its speed and ambition. Federal R&D funding drives new vaccines, cancer treatments, and therapies for rare diseases. Slash the budget by almost half, and the pace of discovery slows to a crawl. Promising drug trials might be halted midway. Laboratories working on experimental treatments could shut down. Scientists might pack up and leave for countries with more robust funding, leading to a brain drain that would be difficult to reverse. The time it takes to bring life-saving medicines to patients would lengthen, and in some cases, cures might be delayed for years or decades. The defense sector would not be spared either. U.S. military dominance rests heavily on its technological edge, an edge sharpened by years of R&D investment in advanced weapons, cyber defense, artificial intelligence, and surveillance systems. A 40% cut would force the Pentagon to cancel or postpone high-priority programs, giving rival nations breathing room to catch up. In a world where China is pouring billions into hypersonic missile technology and Russia is advancing electronic warfare capabilities, losing that lead could shift the balance of power. The consequences wouldn't be theoretical. They could manifest in future conflicts where U.S. forces find themselves outmatched in certain arenas. Space exploration, one of the most visible and inspiring faces of American R&D, would also take a hit. NASA's ambitious plans to return to the Moon, establish a presence on Mars, and explore the outer planets require sustained, robust funding. A massive budget cut would almost certainly delay or cancel missions. The Artemis program might be scaled back, and partnerships with commercial space companies could weaken. Beyond the loss of scientific knowledge, the U.S. could also forfeit its leadership role in space to countries like China, which has been steadily expanding its lunar and planetary exploration programs. In a future shaped by space-based resources and off-world colonies, losing early ground could have long-term strategic and economic costs. Higher education and academic research would suffer a quieter but equally devastating blow. Federal R&D funding is a lifeline for universities, supporting everything from graduate student stipends to state-of-the-art research equipment. Without that funding, many research programs would shrink or vanish entirely. Young scientists might abandon research careers while established professors could turn their attention to private sector work instead of training the next generation. The U.S. has long attracted the brightest minds from around the globe because of its unparalleled research infrastructure. A 40% cut would erode that magnetism, sending talent elsewhere. The private sector, too, would feel the shockwaves. While it's true that many companies fund their own R&D, federal spending often underpins the riskiest, most fundamental work that the private sector can't or won't do. Think about the internet, GPS, or the COVID-19 mRNA vaccines. All had their roots in government-funded research. Without that seed funding, the pipeline of innovation narrows. Startups that might have commercialized new technologies could instead die in the cradle. Industries from pharmaceuticals to renewable energy would face a harsher environment for innovation. Venture capital might flow towards safer, incremental projects rather than transformative breakthroughs. Economically, the effects would be far-reaching. R&D investment is not just a cost on it, and it's a driver of long-term economic growth. New technologies lead to new industries, which create new jobs and generate tax revenue. Cutting R&D spending is like eating the seed corn. It might balance the budget today, but it starves the future. The U.S. could see slower GDP growth, reduced productivity gains, and a weaker competitive position in the global market. This is particularly dangerous in an era where economic leadership is intertwined with technological leadership. Global consequences would be just as severe. The U.S. has been a cornerstone of the international research community, funding projects that benefit not just Americans, but the world at large. From climate change modeling to pandemic preparedness, U.S.-backed research often sets the standard and fills critical gaps. Reducing that contribution by 40% would leave a void. Other countries might step in to fill it, but not necessarily with the same openness or willingness to share data. International collaborations could falter, and the pace of progress on global challenges might slow. Politically, the move would send a troubling signal about America's priorities. Allies might interpret the cuts as a retreat from scientific leadership, while rivals could see it as an opportunity to advance their own agendas. Domestically, the decision would likely spark fierce debates. Some would argue that the money is better spent elsewhere, especially in times of fiscal strain. Others would warn that the long-term costs far outweigh the short-term savings. The issue could become a political football, with different administrations restoring or slashing funding depending on their ideology. The cultural and societal impact should not be underestimated. R&D doesn't just produce gadgets or medicines, it inspires. From moon landings to groundbreaking medical cures, these achievements become part of a nation's identity and a source of collective pride. Stripping away much of that effort risks dulling the country's sense of possibility. Fewer big, bold projects mean fewer moments when Americans, and the world, stop to marvel at what human ingenuity can accomplish. There's also the danger of falling into a self-reinforcing cycle of decline. Reduced funding leads to fewer discoveries, which makes it harder to justify future spending, leading to even fewer breakthroughs. Over time, the U.S. could shift from being the engine of global innovation to being a follower, importing technologies rather than inventing them. This would have profound implications for economic independence and national security. But let's explore what such a cut might look like in practice. The government might start by targeting non-essential or low-priority projects, but those labels are often misleading. Fundamental research in physics, biology, or materials science can seem esoteric until it produces a breakthrough with enormous real-world applications. If you cut in the wrong place, you might be killing the next internet before it's born. Agencies like the National Science Foundation might be forced to reject thousands more grant applications than they already do. The Department of Energy's national labs might scale back on developing clean energy technologies just when the world needs them most. Some optimists might argue that the private sector would fill the gap. Tech giants, pharmaceutical companies, and other major players already spend billions on R&D, and they could, in theory, step up further. But private investment tends to focus on projects with clear, near-term profit potential. The kind of high-risk, long-term research that changes the world, like decoding the human genome or exploring distant planets, often requires public funding precisely because it doesn't offer immediate returns. Expecting the private sector to fully replace government R&D is unrealistic. If we project this scenario over a decade, the picture becomes starker. By year 5, the effects of the cuts would be visible in declining patent filings, fewer scientific publications, and a shrinking share of global R&D spending. By year 10, entire research fields in the US could be hollowed out. Other nations, particularly those investing heavily in science and technology, would dominate emerging industries. The US might still be a major player, but no longer the undisputed leader. Ultimately, reducing the R&D budget by 40% would be a gamble with the nation's future. The short-term savings could be dwarfed by the long-term losses in economic growth, global influence, and quality of life. Innovation is not a switch you can turn on and off at will. It's a garden that needs constant tending. Neglect it for too long, and the weeds of stagnation will take over. In the end, the story of American progress has been a story of bold investment in the unknown. From the Manhattan Project to the Apollo program, from mapping the human genome to developing artificial intelligence, the willingness to spend heavily on R&D has paid dividends beyond imagination. Slashing that investment by nearly half would be like turning our back on that legacy and on the future it could create. The question is not just whether the US can afford to keep funding R&D at current levels, but whether it can afford not to. History suggests that the cost of retreating from innovation is far greater than the cost of sustaining it.